Good. I think we'll call it time to start. Well, thank you very much for everybody joining. Maybe some others will join as we go forward. This is a session focused on ISDAsoil. That's a soil map of Africa, which we've just made freely available via our website, isdaafrica.com. If that's what you were expecting, very happy to have you with us. If it wasn't, well, stay with us anyway. We'd love to tell you about what we're doing and get your feelings of how that is. So I'm Jonathan Crouch. I'm leading the team at ISDA, and I'll be trying to chair this session. We're going to try to break this into three sections. First, a demonstration of the resource. Then we've got some panel members from the private sector that are going to give some feedback on their opinions of it and what it might be used for, and we'll have a discussion after each one of them. And then we'll have an open discussion. We've received some questions ahead of time, and we look forward to any questions from those who are involved in the session. So let's dive in. Matt Miller is our lead data scientist and has been managing this project from the outset, and he's going to walk us through the resource. But before I hand over to him, I just want to take the opportunity to thank our technical partners, particularly Tom Hengel and his group at Envirometrics, who have done some wonderful work in helping us bring this dream into reality. And Tom's also worked with a couple of groups called GI Lab and Multi-One. So Matt, if you're able to share your screen, we would love you to walk through the system.
Yes. Okay, so hopefully you can all see that. So thanks everyone, thanks Jonathan. I'm Matt Miller, the lead data scientist, and I'm just going to spend 15 minutes giving you a bit of background and then jump into a demo of ISDAsoil to highlight some of the functionality. We're calling it a farm level digital soil map of Africa because we're finally at 30 meters geospatial resolution, which we believe is getting towards an agronomically relevant scale, and hopefully by the end of this you'll all be as excited about it as we are. So how did we get here? Well, we took around 100,000 training points, soil samples, across about 15 data sets, and you can see the map here of the locations of those samples. The majority of the data comes from the ASA 1 and 2 data sets, which some of you may be familiar with. About 40,000 point locations across Africa. We've also had significant contributions of data from ISRIC, LAND, PKS, IFDC, and plenty of others to contribute to this. So it's all well and good having point data, but how do we get to a nice consistent 30-meter map? So here's a technical overview that I'll give you some details on that. So just briefly, we did machine learning, ensemble machine learning. We've predicted for about 24 billion locations across Africa. And the first thing we need to do with all this data is standardize it. So we have input soil data from various sources collected at different times using potentially different protocols and so on. So it's all a bit of a heterogeneous mess. So we also need to make sure that the data is harmonized. So for example, there might have been different protocols, different lab techniques used to measure the soil properties. And there was also plenty of artifacts, problems with rogue data points, which could have thrown our predictions off had we not removed them. So once we've got them all into a nice unified database, we then overlay them with our covariates. And these covariates are really important because they're what we use to predict the soil properties consistently for locations where we don't actually have soil sampling information. So we use quite an extensive stack of covariates ranging from coarse satellite data. We use climatic information such as temperature, rainfall. We use digital terrain models, so slope angle, things like that. And about 20 to 30 different other variables. But the important ones really for our purposes and what's helped us move towards 30-meter resolution is these Sentinel-2 and Landsat satellite images. And we spent considerable time and effort preparing cloud-free images, which allowed us to improve our geospatial resolution down to 30 meters. Once we've brought all those data points together, both the covariates and the soil data, we predicted at both 250-meter resolution and 30-meter resolution about 16 different soil variables. We used an ensemble machine learning approach. So we used 5 different algorithms, which are listed there. And then we, again, predicted for both a coarse and a fine scale resolution, and finally merged the results into one layer. And from that, we produce a data layer and an uncertainty layer. And finally, the expert check. So this is really important to make sure that these results make sense to people that understand this. And the whole process was iterative. So we repeated this whole kind of cyclical process about 5 times based upon when, for example, artifacts or strange results were produced, or if we got some new data late arriving. So by the end of it, it's a relatively streamlined workflow. So now I'm just going to jump straight into a demonstration. This is URL, and this is what you should see when you arrive on the ASDAsoil homepage. So this is a pH map, which I'm sure many of you will be familiar with. And the first thing to draw your attention to is this menu bar here. And we have, for all soil properties that we've predicted, apart from the surface variables, 2 depths, so 0 to 20 and 20 to 50 centimeters. We also have this opacity slider, so you can see the underlying layer, which is especially important when you're looking at satellite images, but we also have map images here. And then, as I mentioned before, we also have an uncertainty toggle button. So each layer that we've produced comes with a data layer and also an uncertainty layer, so we know how sure we are of the predictions. So as I mentioned, there's about 20 different soil variables we've made available. We've grouped them into these 4 different areas. So soil chemical properties. So we've got carbon, organic, and total. We've got total nitrogen. We've got pH, for example. And apart from pH, we've coloured each theme a different colourblind friendly colour. You'll also see the legend here, and if you hover over the different colours, you'll be able to see what range of values are assigned to each colour. So then if we move to the physical and landscape properties, we've got various soil textures, so sand content, silt content, stone content, for example. We've got slope angle, which was a data set we produced in itself. We've also mapped the USDA texture classes. This is a categorical variable, so you have to hover over the specific color, and then it will tell you what values are associated with that color. You can also click anywhere on the map, and it will bring up the specific values relating to that 30-meter pixel. We also have macro and micronutrients, so phosphorus and potassium in a different jazzy color, alongside some micronutrients, but not all of them, because some were a bit more challenging to map. And then finally, the agronomy information. So we brought together information that we think will be relevant to agronomic decision making. We've actually brought these in on behalf of the Copernicus. So we've not produced these layers, but we thought they'd be useful, and because they're open access, we've included them. So from 2015 through to 2019, we have cropland cover. We also have land cover. Again, this is a categorical variable, 2015 through to 2019. And then finally, we've created an implementation of the fertility capability classification. Some of you may be familiar with, which was shown by Pedro Sanchez and co-workers. And what we've done here basically is tried to give an idea of the potential constraints to fertility that farmers or anybody else might want to address before they get productive soils. So again, the color scale, if we hover over green is no constraints, and then kind of increasingly angry color scheme towards more constraints. So for example, if we click on the map on the green area, it says no constraints. I should add, by the way, that this doesn't mean there are no constraints at all. It just means of the constraints that we've mapped, there aren't any. And we've only created a partial implementation of this framework because not all the data is available to map all the constraints. Then if you click on a different area, for example, it will tell you low potassium, and that's one constraint. But in another area of the map, it'll say, for example, calcareous, because there's a different constraint. And then, for example, two constraints for another area. So this really, we think, is the sort of direction we want to see ISDAsoil heading, because it's getting more towards decision-ready agronomic information rather than just raw data. So now I'm just going to zoom into a specific location. I've got the lat long here, so you can also enter any location as comma separated latitude and longitude, and just click go to location. I'll just switch this back. And then if we zoom in here, this is actually a field in Kenya that we're very familiar with because it's a pilot project. It's one of the farmers from one of our pilot projects that we're working with. And you'll be able to see that, well, hopefully you can see there's a field, a vague outline where I've got my mouse here. And if I just play this opacity, you can finally see that this pixel size is approaching field level. So those, for example, this 30 by 30 meter square, again, you can see it overlays quite accurately with the fields. And in some cases, the pixels are smaller than the fields. And just for comparison, the cropland information from Copernicus is at 250 meter resolution, and you can see the difference that these coarser data make, and why we think it's a bit more useful at this higher geospatial resolution. So the sort of things we want to be able to do with this, let me just switch back to potassium. Is, for example, site-specific nutrient management or fertilizer recommendation. So our farmer's field over here, it's 180 parts per million potassium, but if we go down here, it's a darker color, which means there's lower levels of potassium. So for example, if we click somewhere like here, 108 or even lower, maybe, no, that'll do. Anyway, it's lower. So the point I'm trying to make is that we're able to vary any recommendation we might want to make for a farmer at the field level. The next point I wanted to make is the importance of the uncertainty. So if we look at the image on the map at the moment, we might say, okay, this is broadly similar. All the soil properties are the same. However, that is not so if you flip to the uncertainty map, which paints a very different picture. So this map again gives an idea of how sure we are of the soil property predictions, because remember, it's all based upon machine learning. So low is yellow, low uncertainty, i.e. we're quite sure of it. Blue is high uncertainty, we're not so sure of it. So if we switch back to the data layer, our farmer's got around 180 parts per million potassium. We go over here, for example, it's also 180, yet the uncertainty is vastly different. And I'm not sure if you'll be able to see it, but we've got this variability information underneath, which gives some idea about the uncertainty. So it's one standard deviation either side of the predicted mean. And on this side, it says it's between 163 and 199 parts per million. Whereas a farmer over here, it's between 120 and around 270 parts per million. So you can see that actually the prediction error is higher, the predicted value is a lot broader. So in practical terms, although the actual values are roughly the same, we still might want to take a slightly different approach when making recommendations for farmers in these two locations. Mostly, for example, a more conservative recommendation for the farmer where we're not so sure of the soil properties, because it means that there's a lower risk of any loss or something like that. And this is something we really encourage everybody who's using our data to be mindful of and consider of, that don't just look at the data, also consider the uncertainty. Also the fertility capability classification, just to continue on a theme of the kind of hyperlocal recommendation. As we might hope that the majority of this area where there's some fields is mapped as no constraints within the soil properties we mapped anyway. But you can see, for example, over here, there's a slope constraint. And that makes sense if you look at that. Looks like there's a river running down here, so it's going to be steep-sided. So the recommendation we might make to a farmer over here could be different, because there's a higher risk of erosion. There might be a higher risk of loss of soil or leaching out of any applied nutrients. If we look to the north here, there's a different constraint, aluminium toxicity, which was mapped as low. So that happens if there's a low pH or a low organic carbon content. So even if the nutrient composition of the soil may be similar for this farmer up in the north compared to our farmer down in the south, we may still want to, for example, recommend an organic manure for this farmer who's got low organic carbon compared to an inorganic fertilizer to the other farmer who's not got low organic carbon. And again, we also might want to suggest they do something about the low pH. So hopefully this has given you some idea of the sort of applications and the direction that we want to take ISDAsoil. So I'm just going to jump back into the presentation and just finish off. So the other thing to note is we've created an API for developers. So anybody who wants to incorporate any information we've got on ISDAsoil into their applications, then they can do that programmatically. So you can sign up for a free API key and access all our data that way via the developer portal. We're also making all this data available via bulk download. So yeah, just to mention, it's all CC by 4.0, so it's completely open data. It's available via Zenodo, where you can download the entire GeoTIFFs, around 10 gigabytes per file. And we're also currently working with the Google Earth Engine team. That's not yet available, but if you sign up to our mailing list, we'll let you know when it is. So finally, I just wanted to finish by saying ISDAsoil is the starting point. We've intentionally made it readily updatable and open access, so that we hope all of you, the community, can help contribute to it, can help supply data with more information to make them better, and also to help identify any bugs or strange looking data. So again, you can visit our website. We've got an FAQ section and technical information. You can sign up to our mailing list and come and talk to us if you have any ideas of how you'd like to apply for it, apply the data. And just as Jonathan mentioned, thanks for our technical partners, Envirometrics, GeoLab, MultiOne, also Rothamsted Research and the World Agroforestry Centre for expert input. Okay, I'm going to hand back over to Jonathan now. Thank you.
Very good, Matt. Thank you very much indeed. So hopefully that gives everyone a bit of an idea of what's inside, and thanks to everybody who's submitted questions. We're taking a note and we'll come back to them at the end of the session. What we'd like to do now is to focus more on the uses, and we want to jump to our panel session. And just to make this a little bit more interactive, we're going to go one panel member at a time, and then open up for questions if anybody has questions for whatever that panel member has highlighted. We'll go through those three, and then we'll come back to a more general Q&A related to the resource itself. So first of all, it's a great pleasure to introduce Ranveer Chandra, who's the Chief Scientist at Microsoft Azure. And I think he's hopefully online. I can't quite see him right now. Ranveer? Yes, excellent, very good. And I think you're going to give us a little bit of background about what you've been doing in FarmBeats and give us a little bit of insight into what you think could be done with this resource. Wonderful. So over to you. Thanks very much indeed.
Yeah, thank you, Jonathan, and thanks, Matt, for the amazing presentation. And I'm Ranveer Chandra. I've been at Microsoft for 16 years. I started the Farm Beats program, which is a tool to enable data-driven agriculture. So with Microsoft Farm Beats, what we're doing is we're building a platform to bring different data streams together. So essentially, in Azure Farm Beats, you can go to the Azure Marketplace, download Farm Beats. It would set it up in your subscription, and then you can start getting data from different data sources in one place, from sensors, from drones, from satellites, from equipment. And then we add the ML tools on top, using which you can start writing your own AI machine learning on top of it to build tools for data-driven agriculture. We are focused on things like, how do you ingest new data streams, how do you combine these different data streams to then start adding value. And if you just search for Microsoft Farm Beats, it will take you to a lot of resources in this space. I started this as a research project at Microsoft Research, and since then it's gained a lot of visibility. Bill Gates blogged about it in Gates Notes. You can read his video and blog as well. So while we are doing Farm Beats, and last year we announced a product on the Microsoft product, I moved over from research to the product side. And since then, we've announced several partnerships with the USDA, with Land O'Lakes, with PepsiCo, most recently with Corteva, where a lot of these companies are building their digital solutions on top of Farm Beats. And Farm Beats, the way we've built it, it's not meant to be a grower-facing product. It's not meant for a farmer to go and download Farm Beats and try it out. It's meant for a lot of people like yourself on the call. It's meant for researchers. It's meant for ag tech companies to start using data to streamline the entire data acquisition and AI on top of that data. So while I've been doing this for 5 years now, more than 5 years, and deploying it in different parts of the world, working with different companies, one of the gaps has, when I talked about data, I talked about satellite data, sensor data, drone data, soil data at different granularities, like for example from Sergo. The kind of data that you saw today about soil, it has been missing at that resolution, at the 30-meter resolution that Matt, Jonathan, and team have presented from ISDA. And that I'm super excited about. That is, when we think of the future of data-driven agriculture, when we think of modeling plants, modeling the farm, until now, we are looking at different data streams to create better models. We are looking at how the plant grows, different phenotypes about the plant. One of the things that has been missing is the ability to map soil at the granularity at which ISDA has been able to achieve. Previously, it was available at a much coarser granularity. It was still useful. But with the new tool, we believe it adds a significant component, a new data stream that can help create these much more accurate AI models about plants. The other thing that I'm very excited about in this tool that Matt presented was the fact that it's not just giving you a value, it's giving you the uncertainty associated with it, which a lot of tools, a lot of AI tools tend to miss, that exposing this confidence in that particular parameter to the users of that. So that, we believe, significantly helps. For example, if I'm trying to model, say, what the crop yield is going to be, if I'm able to take those confidence parameters and put it in the model, my output is going to be much more accurate. So I'm super excited about that as well. The fact that it's not just giving you the values, but also the confidence associated with it. Finally, one of the other things I wanted to mention why I'm so excited about this tool is, as some of you might have known, Microsoft made a big sustainability commitment earlier this year. One of the things that we pledged to do was to go carbon negative by 2030. What that means is that by 2030, we are going to be putting back more carbon into soil than we generate. And by 2050, in fact, we made an even bolder commitment. By 2050, we'll remove all the emissions that we've ever generated from the time Microsoft was founded. And this includes scope 2 and 3 emissions as well. So if you think of that challenge, part of how we get there is going to come by reducing our own emissions. The remaining, we have to buy carbon offsets. We have to buy credits from people who put carbon back into soil, either through forestry or carbon capture methods like the energy companies are doing, or through agriculture. And one of the challenges we run into when we are looking to offset carbon is the entire soil carbon space. How do you know how much carbon has been put back into soil? What does it even look like right now? What does soil health look like? and how much potential there is based on some of these carbon capture techniques. And that's again another place where this tool could be very useful for Microsoft and other companies as well who are making these sustainability commitments, looking at ways to put carbon back into soil and remove it from the atmosphere, where this kind of a detailed model, the one that ISDA is presenting, could be super helpful. So to conclude, I wanted to say that I'm very excited about this progress. Mapping soil and dynamically creating these maps for soil is a very hard problem, and ISDA has taken a significant step in that direction to help address this broader goal of data-driven agriculture and even sustainability.
Excellent. Thanks so much, Ranveer. Really, really appreciate that, and very much look forward to working with you on some of those opportunities and others, and other opportunities with those in the group too. So what we'd like to do, because Ranveer has to leave us in just a few minutes, probably 4 or 5 minutes, was to open it up. And if there were any questions from the attendees, you could direct them straight to Ranveer. And if you want to just switch on your video, we would be happy to bring the session a bit to life and see some of those that are in the background. If you would like to start a discussion with him. And I know you've been putting your questions in the chat line, but I think most of those have been more technical, and we will deal with those at the end of the session.
Yeah, and some of the questions that have been asked, Jonathan, I'm very interested to know about the answers as well. So maybe in a separate call, would love to.
And we'll write it up for sure. Yeah. Okay, fine. It doesn't seem like that's the normal format for these sessions, and I just check if anything came up on the chat line.
So there's a question on soil temperature data. I'm assuming that's not something you capture now, Jonathan. It's more on the soil chemical properties, right, through the ISDA panel.
That's correct. And I think there was also a question about soil, water, and managing drought and that sort of thing. And as yet, we're not in a position to really help with that. But the intention is to build a platform to attract others to partner with us. And all of those other constraints that the smallholders have to face, we would want to resolve those and have a one-stop shop solution for through partnership.
And Jonathan, that's one of the things through Azure FarmBeats we are enabling, is the ability to create a soil moisture map, a soil temperature map. And those are places where until now we were not incorporating soil data at the resolution that you have, but the models that we bring in could be much more accurate with the soil properties data that you're creating at ISDA. So this is one of those scenarios where you could bring together the work that's happening in the private sector with ISDA to start creating maps.
Absolutely. Yeah, very good. I see a question directly for you in the chat line, and that is, I don't know if you see it, how does FarmBeats relate to Azure?
Yeah, so FarmBeats is a cloud platform. So it's a platform that runs in the cloud for data ingestion, data analysis, data AI, and it's a platform for other ag tech companies. So, and it's running on top of Azure Cloud Platform. So if you think of the cloud, when we talk of the cloud, it's these data centers, and Microsoft has a huge data center footprint all over the world in every continent. And on this cloud resource is where we run FarmBeats as an application, as a platform on top of that.
Okay, excellent. So we still have you for 90 seconds, I think, Ranveer. So we're going to squeeze every last moment out of you. Let me just throw to Jamie and Matt and the others that have been looking at the questions on the chat line. Was there anything that you think was worth throwing at Ranveer that you'd rather he tries to answer than we do later? Jamie, Matt?
Oh, I'm not sure any of them are fair to ask Ranveer. I think most of them were asking about details that only Matt's going to be able to answer, I think.
Okay, very good. Well, thanks very much for squeezing us into your tight schedule, Ranveer. We really appreciate it. And we will follow up with you in due course.
Yeah, thank you. Congratulations on the announcement.
Thanks very much. Really appreciate your time. Thanks for joining us. Okay, so now we'll switch to the second panel member, Christy van Beek, who's the Chief Agronomist at Agrocares. I think she has many different hats, but today she's joining us as the Chief Agronomist. Christy, are you online? I can't quite see you.
Yes, I am.
Excellent, very good.
You can hear and see me? Okay, well, thank you very much for giving me the opportunity to join your session. As said, well, my name is Christy van Beek. I do not have that many hats, by the way. I'm Chief Agronomist at Agrocares and Director of the SoilCares Foundation. They are quite linked, but indeed, here I am representing Agrocares. Agrocares is an agtech company based in the Netherlands, in Wageningen, and we develop sensor technology for on-the-spot soil testing. For instance, this device, this is our handheld soil scanner. It has a near-infrared sensor inside, and it's operated via these two buttons, or it's one button with two lights. It connects via Bluetooth to an app on a smartphone. You take your soil sample, you open the app, you scan the soil, the sensor signal is transmitted via Bluetooth to the phone, then the phone connects to our calibration database where it's converted into soil nutrient data, and the user gets a report within a few minutes showing the key soil fertility parameters, and depending on the application, also a fertilizer recommendation with the fertilizers that are available in that area. We started in 2013 with a lot of research and development, and the first scanner was introduced in Kenya in 2017, and now more than 200,000 soil tests are done in sub-Saharan Africa. We are active now in 25 countries, currently focusing on soil, but we will soon release also a feed application to test livestock feed on the spot. So in time, there will be one device with different uses connecting to different databases, for instance, for feed or for soil. I will now focus for sure on the soil applications. The technology is used by our partners. So these are organizations having a network of farmers. So we do not have field agents ourselves, but rather we sell the technology and the licenses to run the applications to organizations who have a network of farmers. So these can be cooperatives, NGOs, input provider, crop buyers, and independent service providers, local governments, etc. It's quite a wide range. We see more and more international companies coming in, requesting for customized applications. So by now we have 35 different applications, all giving soil nutrient information, but with some different flavors or sometimes different crop programs. I enjoyed very much the presentation on the achievements of ISDA. Of course, it's all about data. That's also in our organizations. So the data goes directly to the farmer, but it's also stored in a portal where it's mapped and can be downloaded via an API by the owner of the technology. In our preparation meeting, you asked me to prepare some questions, which I did. But during your presentation, there was another question entered my mind, which I would like to start with. And that is, you said you combine data from 15 different laboratories. We had quite a struggle of developing our calibration database. We started using data from different laboratories, from different sources, only to find out that there is such an interlaboratory variation that it's to build a calibration database to convert spectral reading into soil nutrient data. We decided to start all over again and build a calibration database on one single laboratory. So what we did is we shipped 17,000 soil samples from those 25 countries where we are currently active to our reference laboratory in the Netherlands, where they were all analyzed on 93 parameters. So I think that is the only way to get a very clean calibration database. So that is one of the, I saw in your flow chart that you do some checking, but how do you standardize the different laboratories? So that is one of the, that's my first issue I would like to raise. Then if I'm allowed, I would also like to make my second issue that I would like to discuss in this session, and is how do you actually really bring this to the farmer? Because the title of the presentation was that at the farm level, and I agree with you, with the resolution level, you are probably able to do some good work at farm level, but that is something else than really bringing it in the hands of the farmers. Farmers typically do not go to a website to download a free API. They want their recommendations on the spot, preferably provided by a trusted advisor with whom they can discuss the results. So maybe you could reflect on this, on how you would actually see this reaching the farmer.
Great, thank you so much, Christy. We knew you'd give us a hard time. And we look forward to you telling us whether we managed to wriggle out of those very difficult questions. So the first one, I think, is probably best answered by Keith, because he was the one who, from the very beginning and through AFSIS, had managed that problem. And so I'm going to hand over to for the answer to Keith. I think Keith's just come online. Yeah.
Yeah, thank you. Well, there are clear trade-offs here in the sense that normally the biggest limitation with any digital soil map is the number of ground sample points you have for training the models. So, you know, obviously the bigger the number, the better, but then at the same time, the more different data sets you include, it's subject to more variability. I mean, in this case, I mean, I think many of the points were from the AFSIS projects, where we had the analysis done in only 2 labs, which we've done cross comparison with. We spent quite a lot of time also harmonizing methods, making transfer across different methods from what we could find in the literature. So I think we've gone a long way to try and harmonize and reduce some of these errors as much as we can. In the future, what we'd like to do, I mean, a lot of the points we have are also spectral estimates. You know, we've started this initiative to establish a global soil spectral library and estimation service, which I think you're aware of. And that would be an ideal situation in the sense that we have then spectral estimates based on calibrations done in one lab to very high quality. So the more we get spectrometers out in the field linked to a consistent database, and you have one as well, I think the more we can get around these kind of problems. Yeah, thank you.
Great, thanks very much. And before I give you the chance to tell us whether that satisfied you, Christy, I think the second question is probably one which also overlaps to some degree with that same issue. As you know, a lot of what we're doing is very much at the last mile, is very much on the ground, working with intermediaries, aggregators and off-takers, and trying to collect as much data as we go along. So our motto is very much continuous improvement. So both at the ground level and at the modeling and analytics level. So yes, you're right, there's definitely problems. Historically, that's been a big challenge. But we're trying to work through those. I think what we'd say to the general audience is that this is an initial output from 10 years of investment from the Gates Foundation to make a large step of progress in many of those directions. And we wanted to make that freely available to the community to bring together as much of the smart innovation and other data sets as possible. To start a journey together as a community, and then start building relationships individually with people working on the ground and working out tailored solutions to overcome some of the problems that you've highlighted. So I'm going to throw that back to you. Does that satisfy you as an interim answer, or you'd like to grill us a little bit more?
That was to me?
Yes, yes. Are you satisfied with the answer, or you want
to a certain extent, having good soil data is only one part, of course, of giving recommendations to farmers on how to manage their soils. And also, if we take it one step further to adoption levels, giving a recommendation to a farmer, but then what your ultimate aim is a behavioral change where you want to go to maybe different fertilizer practices or at least different soil management practices. You need a bit more than soil data. So what is your vision on that?
Absolutely. And as you know, we're very much partnership first in all we're doing. We just want to excel at the piece that we're historically focused on as our niche, and build those partners, as we were saying with Ranveer, who are the leaders in data for other purposes. And as I mentioned earlier, build those partnerships with people who have very strong networks, very large networks with smallholders on the ground, who have a lot of historical track record of translating that into adoptable advisory. So we're in no way trying to present ourselves as a one-stop shop. We're very much out there offering what we can do for partnership, as we do with you. So I think I'm going to have to cut you off there for a little while. You're very welcome with everybody else to come back into the general Q&A session. But thanks so much for your thoughts, Christy.
Well, thank you very much.
Appreciate that. And we're going to...
And congratulations with your achievements.
Thank you. Really appreciate it. So we're going to jump to the third, and we had Nathan Price, who's the Director of Crop and Agronomy at Yara, one of the top 5 fertilizer companies, was going to join us, but at the last moment was not able to. But he sent us a very detailed script. And I think, Jamie, you're going to try to do a fair impersonation of Nathan and highlight some of the issues that he would have otherwise said himself.
Well, thanks, gentlemen. Yes, I'm not Nathan Price. I'm Jamie from ISDA, but I'm going to read from his script. We'll keep this fairly brief, obviously, because we don't have his mind on tap. So Nathan was pleased to see soil properties represented visually across Africa, specifically that with the capability to drill down into specific sites. He commented that often in-field analytics simply aren't available or uneconomical in certain areas, and so this is a great tool for that, really as an add-on to in-field work, as well as remote advisory. He was also, as Ranveer was keen to see uncertainty models. He commented, that's a key part of their data work is understanding the uncertainty, so that you know what confidence there is in decision making. We specifically asked him why he thinks it's important and useful. I think I'll just read this verbatim actually, because I don't think I can say it better than his. He said, taking a static data set to a visual and predictive model is potentially a game-changing advance for site-specific soil management within Africa. Well, the accuracy is potentially not where we want it to be from a scientific perspective. And speaking of ISDA, we would agree, we'd love to see that go up. He says this is a significant step in the right direction, as many corporates, government, agronomists and farmers are looking for data to make better informed decisions. He sees applications in food security, informing decisions around land capabilities and soil management in areas where it's previously not been available, it's just been uneconomical. We also asked him how Yara might want to use it, what useful applications they can envisage and that they'd like to investigate. One which was particularly interesting to Nathan was looking at the impact of cultural practices on soil carbon and sequestration. That's something that you can map visually and look at the impact. Remote soil advisory to complement fertilizer advice. I think that won't be a surprise to anybody. As well as site-specific fertilizer recommendations. He was also interested in what's the most limiting factor for crop production in an area, and you'll probably remember Matt's demonstration of the FCC classifications earlier, which I think he's talking about there. But overall, I think he said the most exciting thing was using this information to scale up their advisory. They're doing advisory in various places, but it's relatively focused, and if they can scale it up to reach more smallholders, that's really where he sees the applications. I will leave it there, Jonathan. He did have a question, but I think we'll put that on in our hopper of questions because we've got plenty from the audience.
Absolutely. Thank you very much, Jamie, for being here, Nathan's stunt double. Excellent. So we'll move on rapidly. I think we've already seen that we've got lots of questions already coming into the chat line. So we're going to try to spend the rest of the session on those and any more that come in meanwhile. And our plan was to split those into thematic areas, and we'll see how well we can keep that together. Apologies if we jump around a little bit. So the plan is that the ISDA team will come online now. We've got Matt Miller that gave us the demonstration at the beginning, Jamie who just spoke, and Keith Shepherd who also talked before, and they're going to be the main ones to answer these questions. So I'm just going to kick it off with the question that we get a lot, and we did just get as well, and that is, what's the frequency of the updates? What's the nature of the updates? How's this going to look going through time over the next months and years? And I think I'm going to throw that question to you, Jamie, if I may.
Thank you. I'm me again now, not Nathan. I think what we're keen on is to see the schedule driven by user interest. So we really don't want this to be something where we just follow our own nose and keep updating it without a purpose. What we want to see is where we can improve it, where there's interest from the community, both the scientific and the commercial community, and really drive it from that. We'd love to get more calibration data from the field. There is accuracy which can be added from better remote sensing data at higher resolution, as Matt was talking about before, but it's also key to make sure we get more and more training points. That's really key when you take a machine learning approach. And so really that's key for us. We're encouraging people to share more data. We are also in our own operations trying to feed data back into the system, so that the kind of thing Keith was talking about before. And really what we'd like to see is a self-improving loop go on, that we can improve this resource over time.
Great, thanks a lot. So the other question that we're getting a lot is what's the additional functionality and new ways of using the resource that we envisage? And I'm going to throw that to you, Matt. Yeah,
thanks, Jonathan. Yeah, the one we've had a few times is the kind of area calculation. So can you get this data for a country or any arbitrary area? And again, I think we're kind of collating the information from all the feedback to try and drive how we want to expand the functionality. Specifically on that area question, we've kind of got either extreme at the moment, where you can query by lat long for a specific point, or you can download the entire data set from Zenodo. As I mentioned about the Google Earth engine, hopefully once that's online, you will be able to do some arbitrary area queries. But again, we're really interested in hearing from the users, as Jamie said, to make sure that we're developing it in the direction which makes sense to the community. Thanks.
Great, thanks, Matt. Don't go away, because the next question I think is firmly in your territory too. I think we'll probably ask 3 questions in each of our areas. So the one that's probably came from somebody who is studying in the school of Christy is, well, improved resolution, that's great, but what about improved accuracy?
Yeah, exactly. So it's a fair point. Just because we're going up in resolution doesn't necessarily mean we're creating more accurate predictions. But what we've generally seen from the history of predictive soil mapping is it does tend to be the case. So as we move from 1 kilometer resolution mapping down to 250 meters and now to 30 meters, we've generally seen that the model accuracy, so your R-squared values and things like that, tend to improve. And that's likely because we're using higher resolution covariate data, but potentially more importantly, we're finally at a resolution where we're reflecting the real variation on the ground instead of averaging over larger areas such as you might at 1 kilometre. So yeah, it's also worth noting that, like we said, this is a first attempt, and additional data and covariates are likely to improve the accuracy further. But if we do compare this to, for example, 250 meter resolution predictions for Africa, there is an improved accuracy as well as resolution.
Okay, very good. Right, well, don't go away. We're going to swap seats, and you're going to ask the questions for the next session if you've got that collation to hand.
Yeah, I have. So somebody asked, how can I help with the future versions, or how can I get involved? How can I be part of ASA-CSSA-SSSA's efforts? I think we'll give that one to Jamie.
Thanks for that. Well, we kind of touched on it before, actually. I mean, there are probably two key things we'd ask for. We would love we would love to encourage data sharing, and if people are part of institutions that have data that could be added to this map, we would love to talk to you. Get in touch with us directly. We'd love to talk about this. We would also love to hear about what people are building with the tool. If you want to use the bulk data, or if you're going to try using our API, come and talk to us about it. If there's a feature that's missing, we'd love to discuss it. I mean, our ideal world would be to kind of create some sort of user group for people who are using the resource and take the development further that way. So really it comes down to come and talk to us. That's what we'd like to encourage.
Thanks, Jamie. The next question, I guess this will be a short one. How can I keep up to date with the project? And that's for you as well.
Well, I mean, other than talking to us, as I mentioned before, get on our website and sign up for our email newsletter. You can follow us on social media too, but I think email is probably the best thing to do. We'll be emailing about updates, future plans, any projects that are going on related to it. So if you want to hear more about it, that's the easiest way. Sign up for our mailing list.
Thank you. And the final question is, farmers need help with a wide range of constraints to production. So what is ISDA doing about these more general constraints? And this one we can give to Keith.
Yeah, thank you. Of course, soil is just one part of the information we need to make agronomic advisory, but we're already using it, combining it with economic production data to actually look at the risk involved with fertilizer applications. We're already seeing that when you include risk, it makes a big difference to fertilizer recommendations, and that's where the uncertainty in the soil maps also play out. The other thing we can do with the uncertainty in the soil information is to actually see what the value of different types of soil information are. I mean, when is it worth making a soil test, a spectral soil test, or a more expensive lab-based test, or when is a map-based effort sufficient? So that's one area that we're looking at. But our longer term goal is very much to turn this into an agronomic platform. So we start to add weather, climate data, price data, and so on, to make it be able to project pest disease risks and so on, to make it a truly well-rounded agronomic platform. Yeah, thank you.
Thanks, Keith.
Great. Thanks very much, Keith. So I think that's your three. Matt, we'll let you off the hook for asking questions, but there'll be some more that come back to you very soon. I think we're going to pass over to Jamie now for the next area related to future opportunities.
Thanks, Jonathan, and this one's right back at you. So the first question we've got here is a contact on LinkedIn when we post about this. Asked me, will we do something similar for India? Now, you've done Africa, will you do India?
And of course, when we started, we were called ISDA Global, and then we started thinking about the reality of the task, and we said no, we need to focus on one region at the time, and we decided, because of the heritage of what AFSIS had done, the African Soil Information Service, that we had been spun out of, that we would focus on Africa. But literally every other week somebody asks us about that. And unfortunately, the Gates Foundation have been funding similar type of work that AFSIS has been carrying out in Africa. They've been carrying that out on a state-by-state basis in India. So we've started discussions with them about helping them work in that area, and perhaps ultimately collaborating with them directly. So it's definitely on the radar, but we definitely want to prove that we can make this work very well in Africa first.
Thanks. This one I think is probably best for Keith. We've been asked, do you think digital solutions will replace the need for agronomists and extension agents?
Of course, not completely, but I mean, I think as mobile apps get better, the more information can be done with a sort of remote extension officer or remote agronomist. So while interpretation is important, I think because of the constraints on the number of agronomists, extension officers that can be in the field, we can serve more farmers better by getting digital applications out that can get actionable information to more farmers.
And a follow-up on that, similar area also for Keith. So some agronomists are questioning the use of soil analysis for fertilizer recommendations. That's a topic that's been popping up in the literature recently. What do we think of that?
Yeah, I mean, certainly applies to some cropping systems more than others. I mean, for example, flooded rice is more challenging. But a lot of that is actually driven by the problem that actually Christy had mentioned earlier, that you've got this extreme variability amongst soil labs, which is giving, you can almost get any results you like depending on which lab you sent the sample to. And that is a huge problem, which sort of undermines the value of soil testing. I'll come back to that in a second, but the second thing is, often the importance of doing validation crop trials is omitted or insufficiently recognized. So soil tests always need to be backed up and calibrated with crop response trials. I think an important point. In terms of the lab variability, I mean, I'll just make reference again to what I mentioned earlier, is that, soil spectral measurements are a lot more reproducible than sort of wet chemistry used in labs. And once we link those to a global soil spectral calibration library and estimation service done in one lab, that will really create huge efficiencies and get around that problem. And that's certainly the solution we're looking for in the longer term.
Thanks, Keith. Jonathan, I'm just looking at the time. I was just wondering if we should spin onto the live question.
I think we should, definitely. And Keith, we may come back to you if we don't get cut off at the anointed 60-minute time. We'll come back to some of the ISDA specific questions. But yes, let's jump into a few of those. And one of them was, is there a paper pending around this? And maybe I'll throw that to Matt, because I think you're closest to what Tom's planning to do on that and has been.
Yeah. Yes, there is a paper planned. We're hoping to get it out in the next couple of months. We're just working through it at the moment. So yeah, there will be a paper, and we expect it. I don't want to give too much of an expectation about the date, but certainly in the coming months, we hope to publish it.
Okay, great. And the next one is probably also for you, Matt, so hang on there. What format does data have to be in for people who want to contribute? That's a question we love to have.
Yeah. Well, generally, we find that the data is going to be point data. So in terms of format, whether it's well, to start with, we really will take any data. So we can work with most formats. If it's point data, whether it's in a geospatial database, whether it's simple Excel file, or anything else, really, we can be quite flexible about how we work with it. We can also potentially work with raster data, so more kind of images. So To give you a short answer, it doesn't really matter. The more important thing is that the data is shared with us, really.
Yeah, so just reach out to us and let us know, and we'll figure it out with you. Don't make any assumption that it's not data that we can't use. And we're going to keep going until literally we get cut off, I think. We're not quite sure how this works. So somebody was asking whether the development banks and the international development community knew about what we're doing. Certainly we're working with several of them. We're interacting quite a lot with the World Bank and the Islamic Development Bank. As Keith said, we're trying to build an initiative with FAO under their GLOSALAN program. We haven't as yet engaged with the African Union or the African Development Bank directly as such, but certainly they're on our radar. And that was one of the major sort of desires of the Gates Foundation, that this sort of data would be used by those influencing policy and used for their strategy development. So we're definitely very keen to assist in that space. So we haven't got cut off, so we'll keep going. I think that Nathan's question actually was Nathan Price from Yara's. He was asking to hear more about validation techniques. And I think that's probably a question that we can throw to you, Keith.
Yeah, sorry. Well, I mean, the accuracy measures are already generated through holdout samples and bootstrapping in terms of the modeling techniques. I mean, Matt can also perhaps comment more on that. Definitely that's the way the soil map errors are generated and validated. We are conducting, well, anywhere we're conducting field trials or field experiments or studies of any kind where we're collecting soil data, we're using that as an opportunity to test and validate the soil map accuracy as well. And as I mentioned before, I mean, we're trying to really get our hands around the errors of soil mapping, spectral testing, lab-based testing, and their ability to predict soil nutrient supply capacity, to see, you know, which test is merited under which conditions and at what cost.
Great, thanks a lot, Keith. And maybe another one for Matt, if you're there. Is there a GitHub repository for the code?
Not as of yet. So although the data is open access, the code is not so far, but we can certainly look at making that open, because I don't think there's any issues with that. But again, we'll have to check with our collaborators to check they're okay with that.
And certainly that was one of our dreams in the background initially with the release of this, if there was enough demand, whether we might start to build a consortium for an open source facility. So we're certainly looking to see, you know, is there enough interest to do that? And then we would be very hopeful of sharing that in an open way. Well, we still haven't got cut off, so we'll keep going. Keith, shall we go back to your questions in your group?
Yeah, I mean, key question is, I mean, this is tremendous sort of global good, but how is ISDA going to, you know, maintain this resource in terms of profiting and income?
Yeah, that's a very sharp question. I wonder who that was sent by, maybe our investors. So yeah, of course, we're a social enterprise and we have committed to becoming financially sustainable within the near term. So somewhere in the period of 3 to 5 years is what we're looking at. And we had a lot of discussions both with the investors and our board and our stakeholders regarding this release of this resource. And we decided in this particular case that it was something that we should make public, because we thought we had more to gain by putting it out there and building partnerships and so forth. And so we will continue to support that for as long as we can. And it's going to become are very much the central part of the business products and services that we're developing in terms of tailored solutions on the ground for smallholder advisory. So we have every expectation that it will be relatively straightforward for us to continue to support it. And our main focus is to add value at the farm level in the smallholder value chains, and to capture value at that level, and not at the level of data. We feel that this is a better way to help the whole ecosystem rise up by making this differentiation between open raw data and map data versus paid for services on the ground. I don't know, Jamie, if you wanted to add anything to that or Matt.
Yeah, I guess I'd say another angle on what Jonathan's just said is, you know, the data as it is a snapshot. It's one attempt, and we think that by going to the last mile and engaging with services on the ground, that's a route to get data back that you can then use to improve the open data resource. And we hope that, you know, we won't be the only ones doing that, others will as well. And you know, if we all share, it gives us a common base to work from that keeps growing over time. And I think that's how you get a real lift.
Mm-hmm.
And just something else to add, I guess, that data siloing has always been a problem in science more generally, and we really didn't want to be contributing to that problem any further where people don't want to share their data. So we're hoping that we're encouraging others to share as well by creating this open source resource.
Yeah, good. So another question have been thrown is actually, what is ISDA herself doing with this data resource?
So our primary immediate focus is to develop a virtual soil test and roll that into our agronomic advisory for smallholders. So that's something that we're testing at the moment on the ground in Ghana, and we're hoping to roll that out in several countries as soon as we feel that that's sufficiently accurate. I'm just keeping an eye on the time, actually, Keith. We might wrap up on that level right now. I see there's still some questions that were flowing in. The numbers of people hanging on. Thank you very much for staying attentive. Jamie, were there any new questions that have come in the last 10 minutes that we should address?
Yeah, there was one. This is probably for Matt. So thanks, Umesh. He's just asked, you're using MODIS and Landsat images along with point measurement. His question is, what is the use of the images? Have you used any indices to relate to the soil chemical properties? What's the machine learning model used for the prediction? So I guess that's kind of interpreting the question. I think that's asking, you know, how do the images relate to the soil properties?
Yeah. Thanks. So we use all the different satellite images as inputs to our machine learning models to train the models, and we train independent models for each soil property. And actually, we find that different satellite images, different types of satellite images contribute differently to predicting the soil property. So for one soil property, certain images might be really important. For a different soil property, those same images may not provide any predictive power. So we're using them as input. And then in terms of the machine learning model, as I said before, we're using ensemble machine learning. So we use a combination of 5 different machine learning approaches and take the outputs of all of those. Yeah, that's it.
Great, thanks a lot, Matt. Sorry, we were just conferring. We have some loyal participants. The numbers have reduced now, and so we were wondering whether anybody wanted to switch on their microphone and video and ask a question directly. You're certainly very welcome. We can't believe we're still online, so we'll keep going if you wish to ask more questions. Or indeed, if we have not answered one of the questions that was earlier in the chat box and you would like to get that back on the radar. Okay, well, thanks so much for staying with us for actually now 70 minutes. It's been great having so many people with us. Thanks so much to our panel members and their insightful comments and questions. And we hope you'll have fun using our resource and find some very unexpected uses and let us know. And if you come across anybody with data that you think might be useful for us to continuously improve the resource, then please get them to reach out to us. Great. Well, thanks very much indeed. The technology stood up. Well, that was our greatest fear. Not our technology of the map, but the technology of Zoom. Thanks very much to the ISDA team. And we look forward to seeing you all online, someplace around our maps. Thanks very much indeed.
Right then. Yeah.
Thank you.